for this webinar. At the outset, I would like to congratulate the Department of Chemistry for taking up this program. You know, Dr. B.R. Ambedkar University is entered in the 40 years, and we are celebrating 40 years of its establishment. And our Vice Chancellor is very much interested and very much encouraging all the faculty members to have webinars, programs, seminars, and all academic matters, academic programs in the university. So, in connection to that, has done 2 more webinars before, and now the Department of Chemistry is conducting this webinar. This is the first webinar for the Department of Chemistry. And chemistry becomes very, very, one of the very interesting and challenging subject among all the science subjects. We all know that, all the science people know that. And particularly nowadays after COVID, this chemistry plays very, very important in the field of health. And also it is very, very crucial, plays very crucial role in the energy and environment, agriculture and technology also. And after that, the new trends have emerged like green technology, nanotechnology, and all those things. So now the topic which has been identified by Professor Srinivas Garu, innovations and challenges in chemical sciences in 21st century is very, very apt and very interesting also. I congratulate the Department of Chemistry once again. And I am thankful to Professor Srinivas Garu, who has readily accepted our invitation to give this lecture today for the people in the online. So thank you very much, Professor Srinivas Garu, for accepting our invitation. And I request now Koteshwar Rao to introduce our speaker.
Okay. Respected Vice Chancellor of Dr. B.R. Ambedkar University, Professor Sitaram Rao Garu, Director Academy, Registrar, today's guest of honor, our Dean Faculty of Science, other directors, heads of branches, deans of other faculties, head Department of Chemistry, department heads, faculty teachers, and my dear students. Good morning all, and welcome to the webinar program. This task of introducing our guest and the speaker is a great privilege. He is Professor P. Srinivas Garu, retired professor from Department of Chemistry, Usmania University. He is the student of Professor Navneet Rao, former Vice Chancellor of Usmania University. Professor P. Srinivas Garu is a simple and well-known person in chemistry family in and around Telugu states. He has served 37 years in university level teaching. Sir has served in many administrative positions in Usmania University and continues his service in Syasavahan University as adjunct professor. 7 students are completed PhD under his guidance, supervision, published more than 30 papers in reputed journals, edited 2 books. Sir have delivered about 150 talks in several institutions like IITs, NITS, Central Universities, State Universities, and other educational institutions all over India. Sir, once again, we welcome you. Take over the session. I am thankful to Chair for giving this opportunity. Sir, you can start, sir.
Professor Srinivas Garu. ఆడియో లేదు సార్, చెప్పండి అన్నమాట.
Are you able to hear me? Hello? Hello?
Yes, sir.
Good evening, everybody. We are facing the big pandemic, and we expect it will become endemic. But just now I read some articles. People are suspecting some what you call road bumpings. If road bumpings are not there, this will become endemic and will be better future. And the chemistry is also doing a lot of things in this. And I'll start my lecture. My lecture is a very big lecture, but it is just like a show. I wanted to expose basics of chemistry to the what is happening around the world today. So, what is chemistry? Chemistry is a study of matter and its transformation. Where is matter, there chemistry will be there. The study of matter is called the chemistry. This is what about the chemistry. Chemistry will speak about all the elements of chemistry. If anybody clicks any element about this, you will see the properties of the element from this Royal Society Chemistry periodic table. This is one of the important. There are millions of periodic tables, but one Royal Society periodic table will give the lot of information. Just like if you strike the hydrogen, how electron revolving around the nucleus, you can see in that there's a one great thing made by the Royal Society of Chemistry. I don't know, these pictures are coming on my screen. It is blocking my screen. Okay, now matter will start from the matter, will go to the
invisible, sir.
Yes,
it is.
Remove it. Thank you. So I want to tell
it is visible, sir.
Of chemistry. Matter is made of molecules. Molecules are made of atoms. Atoms are made of electrons, protons, and neutrons. And presently, people know that protons and neutrons are made of quarks, which won the Nobel Prize in the 2002. So this is called the fourth state of matter. So this is the ultimate the states of matter. Molecules, atoms, electron, proton, neutrons. The proton neutrons are made up of the quarks, which is the ultimate knowledge of the matter today. The quarks are two kinds, up quark and down quark. Up quark is plus 2.3, minus quark, down quark is minus 1.3, and these are made up of the what you call the proton and neutron. So this is what we know the states of matter. It is the physical states. Upon heating, the solid becomes liquid, liquid becomes gas, gas becomes plasma, plasma is state. Yes. Plasma is nothing but all the electrons and the positive nuclei stayed together is a fluid state that is called the plasma. So we'll coming to the basics of chemistry. Chemistry is a central science, as just now our madam told. Today, all branches of science are coming onto the bench of chemistry. They are dealt on the molecular basis. The molecular biology, molecular physics, molecular geology, molecular genetics. Every science is explained, every property is explained in terms of the constant particles, that is the atoms and molecules. Therefore, chemistry has become the central science. And the main challenges of chemistry in the world are health and medicines. Now we are seeing in the pandemic, all the medicines are from chemistry. Energy and environment, materials and technology, food and agriculture. These are the four major areas the chemistry is serving the mankind. We'll see one after other little. So health and medicines, the order of the day requirement is prevention is better than cure. So nobody wants to take the medicines, but only prevention. So several vaccines are developed to prevent the diseases. Better sanitation, protect them from infections. Better medicines to treat with the least side effects. This is also another important day today. Is the order of the day. So we are making a lot of drugs. As we know, the isomerism is important in chemistry. Some isomers are poisons, some isomers are drugs. So that's the important criteria. So my intention is to tell you what is the important areas which are now developing. So optically pure drugs. Several drugs are optically active. one isomer is active, other isomers are harmful. So thalidomide is the one morning sickness drug given to the pregnant ladies earlier. So when take these medicines, the people saw the newborn babies without limbs or damaged limbs, and then the people identified that one isomer is drug, other isomer is a very dangerous thing, and people stopped. From then onwards, the optical purity of drugs is coming into the important. FDA, Food and Drug Analysis System, our Indian governments are, every government is trying to stop the, not to issue all the drugs, only optical pure drugs are supposed to be given. So it made drug development. So one of the important chemistry application is a drug development. In this, as a student also, I visited the Reddy Labs. There I hear the lecture there. To make one drug, it will take 10 to 20 years and $10 to $20 billion. And people may screen lakhs of chemicals. And ultimately, we may get chemical and that may give a lot of side effects. So that's the reason CAD, computer-aided drug design, become the hot research, computer-aided drug design. So in the computer-aided drug design, the chemical of drug and the body proteins, how they interact can be seen, and they can predict the drugs. So molecular modeling, that is the topic name. And further, quantitative structure activity relationships are also one of the hot area of research, which is doing a lot of service in the Osmosis chemistry department. Every chemistry teams to work in this field. QPD, quality by design, is another order of the day. So one of my students in the Reddy Labs did PhD on the quality by design. So making the drugs with a new technique is called the quality by design. So like this, several things are replacing the conventional injections. You give a pill which will release the medicine without the use of injections. This is one sample I gave you the how developments are made. So energy.
We can't hear you.
Okay. Okay. Yeah.
No.
Non-conventional energy resources are the order of the day. So major source is only eternal source is the solar energy, and this is the one people have to depend. And next is the nuclear energy, which is abundant, which can be used. But there is a problem with the disposing of the waste. And another important is the wind and tidal powers. They are least available. So solar energy is the ultimate. Sunlight to electricity, photovoltaic cells. This is the converting light into the current is the one of the important source. Or water splitting reaction to produce the hydrogen. Or lot of progress in these areas. People expected by 2050, totally we should depend on the solar energy and solar power. So environmental solutions, green energy and clean energy. So this is what everybody wants, not to pollute. And solution to pollution is dilution. That's what people say in the green chemistry technique. So another part important is the materials and technology. I'm telling only the first challenges, then we'll go to the discoveries. Present time may be called as a material age. New materials are profoundly improved the quality of life. So everybody knows the polymers are changing the world from last 50 years. Liquid crystals, all the digital displays, ceramics, the hard materials, nanomaterials ruling the world now, coatings and adhesives, high temperature superconductors. And present TC is 217, which was reported in the 2017. So smart materials. Smart materials means which will change with temperature, pressure, and restore its original shapes. They are called the smart materials. Self-healing materials. And another important aspect today materials is the graphene. World is spending per annum more than billions of dollars on a single molecule called the graphene. Graphene is one of the wonder material people are using in the all fields, this graphene. And perovskite is another crystal which is used in the superconductors and other important material. So new directions. So diagnostics, just like a non-invasive MRI scanning, application of NMR technique. Just changing the magnetic field, we can see the MRI scanning. Only one field, we can see the normal NMR. But if you change the field across the specimen, you can see the MRI scanning without invasive, unlike the X-rays. Levitating trains. Now we are seeing the super trains is another field. Molecular computing, optical computing. So molecular computing is also another important. So optical computing, instead of electrons, we are using the light. New molecules are using the genetic engineering. New industrial revolution. Novel catalysts for sustainable products. So catalysts are also another important field, especially in chemistry and especially in physical chemistry. Eco-friendly reactions, pollution prevention, these are the new directions. So new materials in the fields of automotive, electronic, biomedical, construction, aerospace, defense, textiles, and sports. So why I am giving these means, for young budding researchers, for young students, where are the fields we can enter means at a glance, you can see some of the hard fields. Food and agriculture. Food and agriculture means everybody wants agriculture means more yield. That is yield rise. That can be done either by fertilizers or the new seed developments. And pest control. So improve the yield and protection is also important. Protection is with pest control and pheromones and weed control. So whatever we give input should only go to the products, not to the weeds. That is the weed control is another important. And chemicals, signal chemicals is also another important, like pheromones. These are the important things in the food and agriculture where chemistry is playing the role. So new areas of chemistry, this also general textbooks are general chemistry, what we read. Green chemistry, benign chemical synthesis. You do any reaction, it should not pollute. That is called the green chemistry. I want to tell you each subject in only one sentence. Nanochemistry. Size changes, properties will change. It's called nanochemistry. Nanochemistry means people think something different. It is only one important criteria. You change the size, properties will change. This is a great thing. From long back, we are seeing the nano properties, but we don't know. We never call it nanometers unless we have seen the electron microscopy. So now the nanotechnology is surfaced after the de Broglie equation and after the electron microscope. So we know the feathers are colored. We use kajal for ladies' eyes protection. Supramolecular chemistry. This is another new branch of chemistry. Non-covalent chemistry. In chemistry means atoms are bonded, molecules are bonded. But in the supramolecular chemistry, atoms are not bonded. They are based on the intermolecular bonding, ion and dipole, dipole interactions, van der Waals interactions. These make the supramolecules. Everybody knows that the permanganate is not soluble in benzene but soluble in water. But we can make it soluble in organic solvents using the supramolecular principles. All the biological reactions, many are supramolecular chemistry, especially membranes. There's a lot of supramolecular chemistry is there. In the biology, a lot of things are there about supramolecular chemistry, but because biology molecules are big, we know little about those things. Combinatorial chemistry. So doing several reactions simultaneously is called combinatorial chemistry, which is just like industrial chemistry. And computational chemistry is a theoretical chemistry. Sorry, instead of doing the laboratory reactions, we can do the reactions in the computer. We can make the interactions of molecules, or we can make theoretical calculations using computational chemistry. This is one of the important applications of physical chemistry worldwide today. So these are the 12 principles made by first the green chemistry developer. Of course, I don't want to describe these. These are the green chemistry means any reaction we make, it should not pollute. That is the criteria. So it is based on the prevention is better than cure. Benign chemical synthesis. The Paul Anastas is the person who made those 12 principles. Sorry. Everybody knows in the kitchen we use the microwave. That is the green technique. Using the sounds, green technique. Water solvent is a green technique. So we use organic solvents which are polluting. Ionic liquids are replacing them. Supercritical fluids, special catalysts, nanocatalysts. These are the areas of green chemistry. And many people don't know that microwaves are very less energy than the IR, than the visible. But those microwaves will make our food cooked in the kitchen, which is one of the green technique. Another supramolecular chemistry. So it won the Nobel Prize in 1987 by Lane. It is a chemistry of molecular aggregates, associates, clusters, or assembles. So not a single molecule. The molecules are aggregated or associated That kind of chemistry is called supramolecular chemistry. Here, just now I told you, intermolecular interactions are playing the role. Biological systems are functioning, mimicking these things. So this is a template for the supramolecular chemistry. A molecule, the precursor will make a complete template, and the template, a guest will sit, and that will function the reaction. So these are the what you call the polyphenol molecules in the cations will built in. These are the type of compounds we see in the supramolecular chemistry. So nanochemistry is a size-based chemistry. Quantum dots means 3 dimension is the nano. Quantum wires, 2-dimensional nano. Quantum wells, 1-dimensional nano. Sorry. So everybody knows that gold is an inert reagent. But if you go to nano stage, then nano gold is a catalyst. So nano in nature, lizard legs has a nanostructures. Bird feathers are nanostructures. The colors of bird feathers. Peacock feathers are colored due to the nanostructures. Butterfly wings, what we see colors are due to nanostructures. Kajal, we use for ladies' eyes, that's called, that has the carbon nanotubes. Ayurvedic basmas, powders we use nanoparticles. Lotus leaf surface contains the nano surface. These are the daily use nanoparticles which you don't know earlier before surface of this nanotechnology. So just as I told you, the size-based chemistry, size changes, the color changes. That is one of the important parameters of this nanomaterials. Size is increasing, it goes to red. Size is decreasing, it exhibits the blue color. That is one of the criteria of this nano colors. So other important field in the chemistry developed is the, just now I was telling you about the medicines, optical pure drugs are the important people are using. So to prepare the one particular isomers, a click reaction chemistry developed by the Sharpless, who won the Nobel Prize in the 2001. So here, just like picking and mixing, just like the biological reactions, the click chemistry. So here, alkyne azide reactions. If you mix the alkyne azide, and with one catalyst, you will get the one isomer. Another catalyst, you will get the only one isomer, and there no impurities are there. We can get directly use it as a medicine, need not purify. That is the specialty of click chemistry. If you combine the two reactions, you will get the ultimately only your product. No pollutants will be there. So that is the click chemistry special. Other reactions are SUFFX, code name, sulfur fluorine exchange reactions, keto acid hydroxylamine reactions, KAHA. These are some typical names given these. These are the examples of the click reactions which are developed. So this is the one example where he won the Nobel Prize for this. Alkene azide, both will give the two compounds. This is with copper, one with vanadium, other isomers are getting. So this was the triggering the new field of science, preparing the particular isomers. So worldwide, this click chemistry has become the order of the day, and very recently, this entered into the textbooks. Less than 2-3 years back, only this entered into the textbooks as the new topics. So the importance of the click chemistry is functional group tolerance, water conditions, shorter reaction time, high yield, high purity, regio selectivity. These are the important aspects. So picking and mixing, you mix all the reactants, you will get your required product. That is a click chemistry. Normally, if you mix all these things, you will get the lot of side products, lot of pollutions, lot of purification techniques are required. But in this, there is no such need. So with the 7 monomers, they prepared over thousands of different individual polymers using this click reaction chemistry now. Optical pure drugs. Sorry. Thalidomide, I told you, one is active, other is a giving the deformed babies. Cetirizine, L is active, costly, R is inactive. Prilosec, one is active, other is inactive. Brufen, ibuprofen, what we use for the painkiller, one is active, other is inactive. Therefore, Brufen, if you take mixed drug also no problem, because one is active, other is inactive, it will be as one of the starch. Nothing will happen with that. But some medicines, one is a pain reliever, other is a liver toxic. Amphetamine, Taxol, methamphetamine, these two are very different. Methadone, R is double active than S. Fluoxetine, 4 times R is active. Pindolol, less than S, renal clearance. So methamphetamine, I want to tell you one thing about the methamphetamine. This is the one people may call it just like a Mattum Mandu. Hitler used to take, his soldiers used to take in the cold condition, then they are fighting there to boost their courage to get the energy, etc. That's the one aspect. But the other thing, the methamphetamine made to lose one player is what you call the Olympic medal. So methamphetamine was present in a Vicks inhaler, one isomer, which is not the drug. The other isomer is the drug. So the person went to London to attend the Olympics, and he took the Vicks inhaler, and that contained this methadone, and people found his urine contained the methamphetamine. His medal was taken back. So although chemists told that they don't know the knowledge of these isomers, and he lost his Olympic medal. So sometimes the basic chemistry understanding public concern is example of this one. And cisplatin is a cancer drug, and trans is an inactive. There is one cancer drug, one isomer is drug, other isomer is inactive. Other common, so to common man realize about the optical importance, carbon meant caraway seeds. So Pudina, Sajira. I want to tell in Telugu because many people don't know this carbon and caraway seeds. Sajira, Pudina, both will contain the same compound, carbon. So we cannot believe that the mint and caraway seeds, Pudina, Sajira completely appear different taste, but there is only one isomer. We can see how the isomer changes the properties. Limonene and lemon. One is in the lime and other is in the orange. Nimmakayalo undetvanti, orange lo undetvanti oka different isomers. That is optical isomers. Both are compound is same, but they are isomers left and right. And what are the future technologies? I told you the future chemistries, but future technologies. Electronics means electron flow is controlled. If the photon flow is controlled, it is called photonics. So if the electronics is replaced by photonics, the speed will increase by lakhs of times. We know the velocity of light is lakhs of times more than the velocity of electron. Therefore, if electronics are replaced by the photonics, the total world will change. And spintronics. So spin up, spin down is used in the spintronics. Just like the 0-1, spintronics are used. And there is the atomtronics. So in the atomtronics, atom flow is controlled just like the electron flow is controlled, just like photon flow is controlled. So this is done in the another important field. Of course, so people are not knowing this. Bose-Einstein condensate, where the Pauli's principle not followed particles are called bosons. When they are condensed, a special state of matter is existed, and that Bose-Einstein condensations, the atom flow is controlled, which is called atomtronics, which is one special field which is yet to grow. And molecular electronics. So instead of this, the molecular electronics also another important field is growing. And other important thing, emerging fields are the most popular fields is the biomimicking, which are done from looking at the nature biology. So gecko-feet, lizards go upside down, how they move. Spider silk, higher tensile strength. Lotus leaf as a water resistant paints. Butterfly wings, display techniques. Sharp skin, reduced drag. Wood ligaments. Toucan's beak, aerospace and automotive applications of water. Spider web stronger than the steel. We know spider web. Housefly, high vision. We don't know that houseflies can see 360 degrees. We can see only front side. But the houseflies can see entire surface 360 degrees. So that vision is copying in the cameras, how to build the cameras. And Nephanthis, lubricants. So Krimisamharaka moka, we know Krimisamharaka moka. When anything insects falls on the plant, it will drag it and kill it. So that kind of lubricants are made now using that mimicking the things. So this one I want to tell you where we are now. People write the chemistry molecules on the board is the third one, and middle one is the atomic force spectroscopy. Top one is the electron microscopy. So now we will say that what we write on the board can see in the spectroscope with the atomic force spectroscopy. This was developed in the 2013-14. This picture I took from the internet. So atomic force spectroscopy is directly viewing the molecules. That is the order of the what we write on the structure of the molecule on the board, you can see through the atomic force microscopy. People should know this. People are making structures in such a way that your task can charge the polymers. Your class can release insects which can kill the mosquitoes. Your class can kill the bacteria 99%. Your class can have a colors with the nanotechnology. And yesterday I have seen the textiles. One side it will become as a woolen cloth. Other side you will see as a cotton glass. You can wear them in winter. You can wear them in the summer. So those cloths are used. Junex textiles. Yesterday I have seen in the paper. Junex textiles. They made the optical technology, optical computing technology to make those textiles. One side cool, one side hot. This is one of the greatest technology developed in the textiles. There is a lot of chemistry in that. So another thing about because many chemistry students are biology students, but originally people thought of mathematics people, but now many biology people are entering. Just for those people, I collected something. There are some plants which will change our taste. People know that when we see what you call usuri, we feel the taste is changed. Like that, there is a plants. These plants will change the taste of our tongue when we take them. One is called Podapatri and other is Miraculin plant. Other is Curculigo. Other is this is Sargon. So these are the plants which will change our taste. So one of the important aspects of these things is some of the chemicals present in those will block our tongue sensors, or well, they activate some sensors on the tongue. So that's also one of the important chemistry aspects in the living systems. And next, I just was telling the future computers may use light instead of the electrons. So this is one of the important, just now I told you, lizard legs have the nanostructures. The lizard legs structure is mimicked by the scientists. They made the hand gloves with the lizard balli called structures mimic చేసి they made the gloves. Using those gloves, they scrolled on the glass with a 25 kg backside. So it's a miracle. So lizard legs nanostructures have an unusual phenomena. They are sticking to the surface with the nanostructures. They are called as the setae. So these setaes polymers are prepared and gloves are made. Those gloves are helping to move on the glass. These are the structures of the lizard legs. So just now I told the atomtronics trying to replace the electronics. Oh, one of the important things I want to tell you about the people use the copper vessels in this. This has one important application because of my lecture. I want to tell you some of the things may not be available in the books. So there is a one virus called the norovirus. That norovirus is extremely difficult to kill. But when we use the copper vessels, 98% of the norovirus is killed by the norovirus. So that is one of the important applications of the copper vessels in the cooking or copper vessels heating. They made a lot of research on this by changing the percentage of copper, increasing the percentage of copper, the norovirus is killed. So people want to get energy from the radiation emitted by the earth. So earth gives the warming radiation that is called the infrared radiation. That is to be trapped to energy. And particle control in quantum field. So in the 2012 Nobel Prize is given for one important aspect of this science. So you can interact the individual atoms with the light. And with molecules, you can interact the light. So individual atoms identification is made in the 2012 and that won the Nobel Prize. So one can interact with the individual particles is the greatest order of the day, ultimate that is achieved, and that won the Nobel Prize in the 2012. So one can meddle with the individual atoms now. So one of the battery technologies, the battery tires need not be, the car tires need not be weighted. From that, lithium-ion batteries, electrodes can be made. One product is, one research is published recently. Another thing, this slide is made because when I was giving lectures, one of my teachers asked me a question. So people can convert light into matter into light. E is equal to mc square. We know the Einstein equation. But can we convert light into matter, which is very difficult yet to done. But in principle, we can make it because there are some symmetry principles are there. So that one paper I collected. this. But as on today, nobody converted radiation into matter. But matter converting into radiation is a known phenomena. E is equal to mc square. There are some symmetric constants which are there. So this is one of the important to make the cellulose into just like iron wires. So when you pass the cellulose through the small holes, just like cotton is converted into threads, the cellulose is converted into the linear fibers, which are much stronger than the steel, are made using the passing through the cellulose through the holes. So another energy production is the where river water meeting the sea water, because of a difference in concentration of salt, there you can generate the power. That's called the pressure retarded osmosis, used to convert the this osmosis potential into energy. Where river water meeting the sea water, there you can put the membranes and you can convert this into the energy. And this is one important thing every university teacher, every researcher, every scientist has to see that. So every hotel, every household wastes the kitchen waste, especially tomato skin, which contain the particular chemical, what you call as the that chemically is converted into the polymers and used by the Ford company. So this is one of the important applications. One industry and another waste both combined, and they made the Tom Auto through efforts of Ford company and Heinz company. Lycopene is the present in the tomatoes. That red color is a lycopene. That lycopene is converted into the products, and that products are used in the car parts. For us, it is a waste. For it is an industrially used application. So this is everybody wants the car batteries now. People are making the simpler batteries using the simple cell. Also, they convert, split the water and produce the hydrogen, but it is yet to materialize to the large scale. So using the 10 rupee cell, we can produce hydrogen that can be used as a fuel. So this is one of the important biomimicking technique. All of you know the cockroaches, they move in the world, but they have a sensing technique. They sense the living problems. When some earthquakes occurred, buildings inside some living population may exist. So they send the cockroaches with an instrument. If at all there is a living people are there, the cockroaches will go to them, and following that, people can identify living people are there or not. So this is one. Sensing of the cockroach is used for detecting the living people inside the what you call the earthquake buildings. So this is another important biological wonder. Of course, I don't call it a chemistry, but there is some case you will know this. So you have a tomato plant, on the ground tomato, inside the ground a potato. This is one of the important recently reported. So other important non-invasive technique. If you want to tell the sugar test, you have to take the blood out of it. But just put your hand on the mission. The light reflected can measure your blood sugar. This is called the seeing glucose through the skin. But I don't know this has to commercialize. But I have seen this research reported. So you send light onto this hand, and reflected radiation will give you the spectra, the percentage of sugar in your blood. So this is a rewritable paper. Every day we are wasting a lot of paper in printing. So this is a paper, a rewritable paper is made with the synthetic polymers. So molecules do talking. Instead of the electrons or these things, molecules are talking is another phenomena. Devices cool itself in blazing hot sun. So this is one of the important inorganic chemistry have seen. So on the surface of the house, on the rooftops, you coat some chemical. What happens is, there's one important figure you see, 8 to 13 micrometers. This is the light not absorbed by the atmospheric gases. So what happens is, the light is falling from the sun on the earth and on the surface molecules. The surface on the moon is cool because there is no atmosphere, there is no warming. But on the earth, there is atmosphere which is getting warm. But this atmosphere absorbs 8 to 13 micrometers. So the light falling on the surface of the rooftop is absorbing remaining one. The 8 to 13 is emitted. Then that is cooled. So they found a chemical which is absorbing 8 to 13, that is chemical called silicon dioxide and hafnium oxide. So hafnium oxide is one which absorbs the radiation which is supposed to be absorbed by the atmosphere, and when you coat this, the temperatures below are 10 to 15 degrees cooler than the atmosphere. This is one important inorganic discovery. So human generated space, you are sending the several satellites out into the space, and the space can junk there lot of things. So for that purpose, one Indian scientist made lot of research. So whatever you use, the food can be converted into solid waste and liquid waste. All these are converted into the useful chemicals and fuel by his research. Human waste turned into fuel for returning flight to Earth, so that whatever you take food, that is converted as a energy, and nothing will come, nothing will be left in the satellite. So I was giving a lecture at the BB College on this day. I saw a photo. In the UK, a human bus is running the human waste on the demo. This is on the 21st November 2014. I read an article. A bus is running on the human waste. Really, it's a surprising thing. So disposal is a problem, but that human waste is generated as a energy which is running on bus. And this is the most surprising. Now we are seeing the sitting in a car, we could able to see the route. But when you apply this GPS to molecules, you apply GPS to a drug which you are taking, and how the drug is traveling in the blood is seen once. They have seen the GPS application to a drug which is flowing through the knees where the drug is changing. Other leg where the drug is not changing. They compare the drug in the two sides. How the drug is changing is observed with this GPS applying to the molecules. I don't know, this also not surface, but this is a lot of research is done in this. If this is done, we can see how the chemistry is changing in the body. So how a drug is flowing to the body is monitored using the GPS onto the body. So engineering students are putting off the flames using the sound. The sound is putting off the flames. So this is one of the important pollution, because I wanted to collect the different kind of things which are essential to know or essential to implement. People know the pollution is only carbon dioxide, but one of the much more 100 times efficient pollution is a methane. So our animals will give methane. Our food products, food cultivation also gives methane. So rice is one of the biggest contributor for the methane. So genetically modified rice, which is giving less 90% of methane, is developed recently. So this is a fastest camera. On a fraction of a second, you can take the billions of photographs, and this will allow us to see the flow of electrons through the body. So one of the important aspects is the cyclone storms are affecting the phytoplankton. As a mathematics student, I was not aware of this. The 60% of oxygen on the earth is due to the phytoplankton present in the ocean. Nobody knows this, normal people. So in the ocean, phytoplankton is there. That phytoplankton is responsible for the 60-70% of oxygen in the earth. So that is going to be affected with the solar storms. So that is one of the important aspects noticed present day. So synthetic artificial leaves are developed to use them for photosynthesis. And artificial hearts are created with the plastics. Hydricity concept. So you make the water heater, preserve it, and whenever you want, you cool it, and that energy should be converted into power. Heat the water with sunlight, convert heat water into cool water, and that energy converted into electricity is called the hydricity. So we can use the nano membranes to convert the seawater into salt water into the fresh water when they are passing through these membranes. So cell phone is used to diagnose the molecular tumors in the body. So could light be used as a future pesticide? Now spreading the chemicals on the plants is becoming a lot of difficulty. People are using the research to kill the insects using the light. So insecticide is replaced by the light is another area. And putting the bacteria inside the body with a positive purpose. to curing the diseases. People are making the sensors in the car to detect the drunken drive. I think people know that if you get into the car, if you not put the belt, the car will not start in the US. But here, people are making the car in such a way they are putting sensors. If you are drunken, the car will not move. And one recent finding I've seen in the research, this is some malaria and cancer. A pregnant woman getting malaria is affecting a particular protein. That is the protein getting affected in the cancer patient. This is also one recent finding. And people are thinking that in the Gulf countries, petrol is wasted over and future maybe the deserts difficult. But people are finding the research, the desert dust is a source of energy for converting it into the electricity. So some of the vibrations are made to convert this low energy conversion. So some of the tests are made to find the optically pure compounds, tartaric acid, and these new reagents are made to detect the optically pure compounds. So this is, I want to tell you to all the people, in January, we eat the sesame, what is called nuvulu. This black sesame is a excellent remover of the what you call the lead, the cadmium, the heavy metals or poisonous metals from the body. These sesame has a chemicals compound ligands which will catch hold the poisonous metals from the body and remove out. So this one of our chemistry professor, Dr. Devadas sir, former head, did research on this also. A lot of people did. So sesame is one of the good food to eliminate the poisons from the body. So carbon dioxide are converting into the useful products. Carbon dioxide directly converted into the fuels. So here Palema, sorry. So these patches are made with the sensors without doing any tests. You can see the body composition with a sensors, with a transparent sensors. Again, I told you the Grubbs catalyst is made to convert the tides. Another new compounds, fluoroalkyls are used to new chemicals. Catching the sunlight, new chemicals are made. World is ruled by another technology called CRISPR-Cas, gene editing. Just like a tailor will stitch the cloth as per our body. The CRISPR-Cas is a gene editing technology. CRISPR is a gene editing technology. Cas is called molecular scissor. Cas will cut the gene wherever you want, and the CRISPR will repair the genes. And whatever kind of children you want, whatever kind of things you want, you can develop using the CRISPR-Cas. The CRISPR-Cas technology is applied onto the animals, and you might have seen the lamb is born with this technology, and people are not allowing this to the human beings. And one scientist last 2 years back made research on the human beings, and he was kept under arrest. And this is one of the great research. Many diseases can be cured with this genetic diseases. CRISPR-Cas is one of the greatest technology. So a small technical tiniest engine is sent into the body, which will detect the inside the body. A spectroscope is developed to find egg is male or female. So this is, just now I told you, atomic force spectroscopy is giving the structures of the molecules. And one of the important things, so whatever I'm telling you is not only great science, but the common man science, and which is wondered. Everybody knows the silkworms. In the silkworms are fed with graphene. They give the silk which is conducting and which is highly strong. It's a really funny thing. We know the silkworms give the silk. Whenever you fed the silkworms with the carbon nanofibers or these nanomaterials, the silk is strong and the silk is conducting. This is a great research recently made. But there is one biology. So when you give these nanoparticles to the worms, anyway they are going to kill. But what is the biology effect? I don't know. Sweat-based sensors. Just from the sweat, we can identify the body compositions. Sorona is a new polymer. One industry made a polymer. So this is the people who has to learn from the university or in the industry. They made a polymer 30% from the plants and 60%, 70% from the synthetic. They made a polymer Sorona. One person came from the one country to the Surat. He made a crores of business on a single day, saying that this is 30% made from the natural products. So the worldwide made billions of dollar business using this one. The Sorona is a copolymer made with a 1,3-propanediol. This 1,3-propanediol is obtained from the plants. So the plants is giving the one alcohol which is introduced into the clothes, and they are called as the semi-synthetic class. That is the biggest business. So these are the some of the things every day we see in the newspapers, scientific. So to know the awareness, is a compound interest is one of the site where you get the recent topics. So this is a one important thing. A small industry, you can put it in the pocket and you can take biological drugs on demand. A portable device, you can make the drugs wherever you want in the villages. You need not go to the industry. So this is a nanotech powered clothing, ionic liquids. So this is one, they made a glass, one side is 1,000 degrees, other side is 25 degrees centigrade. Means they made a such a glass, such a thermal resistor, one side is 1,000 degrees. 1,000 degrees we can't imagine which will be in the furnaces, which can, but one side is a 25 degrees. Such a glass is prepared. So these are the some of the recent developments published every time. Sensor materials are developed. Orange is a paramagnetic, deep is a diamagnetic. So the magnetism can be distinguished with these reagents. New technology batteries. Artificial leaf. So this is a synthetic, this is a natural. The radish on the right were grown with the help of the bionic leaf that produces fertilizer with the bacteria, sunlight, water, and air. See, this is the water order of the day. This is with artificial leaf, this is a natural one. So, another important thing people are seeing today is the quantum computing and quantum telecommunications. So, if I talk, you can hear and middleman can break up this. So, if you use the quantum entanglement means one electron is up, other electron is down. So if you make the first electron down, second electron will become up. So two are interlinked. So one is up, other is down. So this kind of quantum entanglement is used in the communication. 2016, China sent one satellite to the space. That communication cannot be broken by anybody. So this is demonstrated here in one experiment. A light is sent through the cat image. A light is sent without the cat image. The light sent through the cat image will not give the image, but the light will go through without cat image will give the cat image. So this is a great wonder. So before splitting the light, there is one wave is coming. But once this wave splitting into two parts, one wave gives the image, one wave does not give the image. So the wave which is passing through the cat will not give because that is IR. The other wave is giving image because this is entangled with the first one before separation. So with the quantum entanglement, we could see the image of this one. So this is a great wonder. Quantum entanglement is the greatest thing. Future world, we are going to see greatest thing in the quantum entanglement. Sustainability. Ford and McDonald's collaborated to convert coffee beans into skin into the car parts. Just now I told you the tomato skin. Next is the coffee beans also converted into the car parts. Human organs are fully transparent made. Getting inside dark snows. So what is there in the dark snows is mimicking in the regular mass spectrometry. Mosquitoes engineered to repel dengue virus. And one more thing I want to tell you about the mosquitoes. So last year I have seen the one, they made the project in the Florida. They are making the mosquitoes, when they mate, they become impotent, they cannot regenerate. So that kind of mosquitoes are made to end the generation of these mosquitoes. So the genetically modified mosquitoes atomicity at the nanoscale. Super batteries are made with the salt. Converting radiation heat into. So these are the kind of things. These are 2000. Every year end, you will see the important discoveries list that is called in the. Can sample sweat can be used to replace the blood test. This is a quantum technology, super secure communication with the quantum entanglement. Non-invasive blood sugar tests. Molecular windows. So people know the NMR spectroscopy and MRI scanning. So individual molecules are seen through the NMR by a environmental scientist. Molecular windows. Through the window, you can see the person. But through the molecular window, you can see the individual molecule. This is one of the latest advances in the NMR technology. Single writing events in novel magnetic memory. So antibiotics are made using the artificial intelligence, which are more powerful. So these are the, this is also this week in science will be there. This for only information, anybody is interested, they can read these kind of things. Every week we'll see the developments. Mixing silkworm with polymers could lead to a better biomedical implants. So polymers and silk are mixed to make the bioimplants. So this is what insect wings are used in the superbugs. So regarding the corona, we see a lot of vaccines. Vaccines purity is checked with this what you call the crab's blood. So people are afraid the crabs may extinguish because this much, just like water, people are using the crores of doses of the vaccine. The vaccine purity is checked with the crab's blood. This is one of the important use of the crab's blood, which is not red colored. So this is the recent developments. This I will tell you, this is one of the important thing. So Earth Biogenome Project. So to make the human genome worldwide, it took 11.5 years. But now people are making the genome sequence in minutes. So internationally, they decided to make a Earth Biogenome Project. Whatever the living species on the Earth is going to be sequenced within 10 years. Already lakhs of genes, lakhs of organs, genes were encoded. It's a big project. Yesterday I was seen in the paper, Earth Biogenome Project, which is making the genome sequence of every living things on the Earth. So this is the last year entire chemistry development I have seen in the net. You can see this, but small things, whether you can read it or not, but if anybody wants, I will forward this lecture. Thank you for your questions. Thank you. I am not saying that I explain you something, but I can show, I only shown you the what is happening around the world, what are the requirements and what is achieved so far. I told you. Thank you for your patience. Thank you and all. I thank the Vice Chancellor Sitaram Rao Garu and the head department, Dean, Registrar, and our beloved physics chemistry friend Kotesh Rao and all others who are present in the lecture. Thank you and all. Thank you.
Thank you, sir. Thank you, Professor Srinivasa Garu, for your nice presentation. And you have explained very well how the subject of chemistry is playing a vital role in all other fields. And as well as you have explained very well about the innovations in all, you have touched upon the innovation of chemical sciences in this 21st century. And also very much interesting to know about the developments of the emerging technologies like atomtronics, spintronics, photonics, molecular and electronics. Particularly, my attention is on molecular surgery, which you have explained about the CRISPR, and also knowing very interesting about the quantum entanglement also, which are going to play a very crucial role in the future in generations. Sir, really thank you very much for your wonderful presentations. You have really enlightened us with your presentation. Now, this webinar forum is open for discussion. The students or other faculty members, those who are interested to say something or ask something, you can please unmute and you can ask the questions. Sir is here. Thank you very much, sir.
Dear participants, you can ask him any question related to this subject.
Good afternoon, sir. Your presentation was very interesting, and you covered all the recent trends in chemistry and what is the new research is going on. Sir, my name is Nagraj and MSc Chemistry second year, sir. Sir, I have two questions, sir. Okay. The first question is that, sir, when you are given information about hydrogen fuel cells, so my question is that, sir, so what is going to be the new research and what are the limitations and what are the advantages and what are the challenges we are going to face in using hydrogen fuel cells? And also, sir, one more question, sir, in treating wastewater treatment technologies, otherwise to treat the particular lakes, sir, we have facing a lot of problems in river treatment, all those things. So what are the new technologies can be used and what are the challenges we can face, sir? Thank you, sir, very much.
Coming to the hydrogen, the production is made with the different techniques, but using for mass purpose is a little difficulty, and storage is one of the safety is the biggest concern. But a lot of technology is developed, no problem with the technology, no problem with the chemistry, but converting into the bulk and making into common use is one of the biggest problem. But the water treatment technologies are there, but people or governmental agencies has to adopt those and make that. And before that, the simple advice, prevention is better than use. So because the technology is developing, the water sources should not be communicated. Water source pollution leads to so many successive pollutions. So when one water is polluted, people knows that in the Uppal the water is polluted, and all those what you call the agriculture products are getting polluted. So therefore, in the beginning source itself has to be made, the treatment should be made before that one. So I'm not a what you call a government agency, but as a chemist, prevention has to be made with the sewage treatment plants. And once it is entered into that one, is a ocean. Ocean problem is also ocean. Purification is also, the problem is a big task. So that's the only advice. Thank you, friend.
Sir, could you please elaborate a bit on norovirus, what you have mentioned just now in your presentation?
Madam, I'm a mathematics student, but I read this article and then I surprised. The earlier people used to have these copper vessels. Then I realized the norovirus has no medicines, which is very difficult to cure with the medicines one were getting affected by. But this copper is controlling that one. Copper is killing the norovirus. So immediately I added this into my slide and I sent it to the friends. Because I made it a big lecture to exposure. I'm not concentrated on the initial aspects much.
Okay, sir. Thank you.
It's just like show, madam, because I shown this about 30-40 lectures I made on this from the scratching of chemistry to the what is happening till yesterday. I wanted to cover that my interest so yes, that people can have the idea.
Yeah, yes, sir. Thank you, sir.
Anybody wants, I'll send this lecture to my student, Dr. Pramila. You can have it. Science is for use, it's nobody's property. So I'll send this to her. Let anybody can use it.
Okay, sir. Thank you very much.
Thank you.
Yeah. So, Koteshwara, can you please wind up the session with your vote of thanks?
I deem it a great honor and privilege to deliver vote of thanks. First, I thank Vice Chancellor of the University, Professor Sitaram Rao garu, and Director Academic and Dean Faculty of Science for giving support for arranging this webinar. And also, I thank directors, deans, and heads of the branches, heads of the departments, faculty members, and participants. Finally,